Hello everyone, I'm Professor Harrison and welcome back to our module on regression for finance. Today we're going to be covering model specification. That's the choice of which variables you put into a regression in the first place. And we're going to focus on what happens when you leave an important one out. This has a name, omitted variable bias. We're following Margot, a graduate student trying to reassemble a story her family buried. Today she's further investigating the mystery by reading another one of those mysterious letters addressed to her grandfather. Every regression starts with a choice, and it's a choice that's easy to make without realizing that you're making it. Which variables go into the model? Up to now, we've mostly taken the variables as given, but in real work, you decide. You decide what belongs on the right-hand side, and that decision is called model specification. It ends up mattering more than almost anything else you do, because the variables you include are going to give your coefficients their meaning. So let's talk about the most important way specifications can go wrong. When we first wrote down a regression, we said that the error term holds everything that affects the outcome but isn't in the model. Most of the time that's fine, but the trouble starts when one of those left out things is also correlated with a variable that you did include. When that happens, you get omitted variable bias. Here's the plain version. If you leave out a variable that actually affects the outcome, the regression can't just let that effect disappear. That effect gets absorbed by whatever's left in the model. In the classical case, the missing variable is correlated with the one you kept, and its effect gets soaked into the variable's coefficient. The coefficient ends up measuring its own effect plus a piece of the missing ones, so it's no longer measuring what you think. That distortion is omitted variable bias. Let's look through an example to see how this plays out. A common trap that fools a lot of professional investors has to do with how we measure fund performance. Suppose you're looking at a fund with a fantastic track record, and you want to know how good the manager really is. The problem is that most funds have very different risk profiles, so if you just look at the raw returns across different funds, you won't necessarily pick the manager who has the most skill. Instead, the most common way to measure performance is to regress a fund's return on the returns of the broader market. This will give you back two numbers. The slope will tell you how much the fund moves with the market, which is just a measure of market risk exposure. The intercept will tell you how much the fund's average return ends up being higher than what's expected to once you strip the market out. That intercept is the part that the market can't explain, and it's often called a fund's alpha. And it's the number that's supposed to capture the skill of the fund. On both of these counts, the fund looks wonderful. The alpha is high, so it looks like there's real skill. And the market exposure is low. A fund that simply tracked the market would have an exposure of 1, and this fund comes out to around 0.6. So it looks like the manager is earning all that return while taking on noticeably less market risk than the index. So high returns and low risk. That's the dream of any fund. But here's what the model can't see. Exposure to the broader market isn't the only risk out there. And in fact, the fund was tilted toward two things that the regression leaves out. It tended to hold a lot of smaller companies, and it tended to hold a lot of cheaper value-priced stocks. So why does this matter? Well, there's two things that are true about these tilts over this period. First, size and value tended to pay higher than average returns over this period. In general, size and value stocks typically end up paying better because they happen to be riskier investments. Second, over the fund's history, they tended to move against the broad market. So when the market fell, those tilts went up, and when the market surged, they lagged a little bit. So watch what that does to our two numbers. First, these extra returns from investing in the size and value premiums has to go somewhere. The only place left for it to go, for a steady unexplained return, is to sit in the intercept. So the alpha drinks up the premium and looks like real skill. Meanwhile, because the tilts moved against the market, they partly canceled out the fund's real market swings. In our first regression, the regression sees a fund that didn't seem to move very much with the market, so it reports a low market exposure. The tilts are effectively masking how much market risk the fund was actually taking on. So now let's run the model with those tilts included. We add the size tilt and the value tilt as their own variables. And because we covered this back in multiple regression, each variable only gets credit for its own effect while holding the other ones constant. Now two things move at once. The two tilts soak up the premium that was theirs all along, so the alpha, the part that looked like genius and true skill, falls from around 4% a year down to only around 0.5%. And with the tilts no longer masking anything, the fund's true market exposure goes up. It jumps from that comfortable 0.6 up to something like 1.3. So in reality, the simple model got both numbers wrong. It made a risky fund look safe, and it made an ordinary manager look brilliant. So how big is the bias, and which way does it push? There's a clean way to think about it. The bias in a coefficient ends up being the product of two things. First, how much the missing variable actually moves the outcome. Second, how the missing variable lines up with everything you actually had in your regression to begin with. Multiplying those two, and the sign of the bias is just the product of the two signs. Look at how this plays out here. The tilts pay a positive return, and that first piece is positive in both cases. For the market exposure, the second piece is how the tilts relate to the market, and they moved against it, so that piece is negative. Positive times a negative is negative, so the market exposure got pushed down, and that's why it looked low. For the alpha, the second piece is just the steady premium that tilts pay on their own, which is positive. Positive times a positive is positive, so the alpha got pushed up. So the same missing variables, two different coefficients, biased in opposite directions, and both in directions that made the fund look better than it actually was. An omitted variable bias like this can be a real problem, and unfortunately it's not something that you can just collect more data in order to get yourself out of trouble. The bias doesn't shrink as you gather more data because the problem isn't just noise, it's a missing piece. The estimates stay centered around the wrong numbers no matter how big the sample gets. Statisticians call that inconsistent. And inconsistent just means that as you collect more data, instead of zooming in closer to the truth, you zoom in closer to a bias point far away from the truth. Now you might think the safe move is just to throw everything in. If leaving a variable out causes bias, then why not include every variable you can get your hands on? So let's look at the other side. Suppose you add a variable that has nothing to do with the outcome, something that returns genuinely don't depend on. The good news is it doesn't bias anything. Your other coefficients stay centered on the truth, but unfortunately it isn't free either. Every irrelevant variable that you add makes your estimates a little bit noisier. The standard errors get wider, so you end up less sure about the coefficients that you actually care about. You haven't introduced bias, but you've given up some of your precision. So that's the real tension in specification. Leave out something that matters and is correlated with what you kept, and you get bias. Pile in things that don't matter and you get noise. The challenge is to find the right middle ground. You want to include variables that belong, but leave out the ones that don't, rather than letting the model make that choice for you by accident. Margot sets down the letter. For weeks she's carried a model of this whole thing around in her head. In her mind, her grandfather was the victim and the rational quant was the predator, and every letter was an attack dressed up as advice. But that isn't exactly what she's reading. The tone was never adversarial, it was patient, and it was teaching, letter after letter. The rational quant kept handing Victor the one thing that would have protected him, which is a clearer view of his own risk. And she realizes her own model had a variable left out of it. The omitted variable in her mind was intent, and without it, her read of the rational quant came out biased, the same way that the fund's numbers did. Whoever was writing these letters was offering her grandfather transparency. The name on the incorporation papers, Ruth Sokolova, still sits there with no story attached, and Margot still can't reconcile the two halves of it. Why would someone who wanted Victor to see so clearly also take everything that he had? So that's the model specification. The variables you choose to include are what gives your coefficients their meaning. Leave out something that matters, and its effect doesn't just vanish. It gets absorbed by whatever is left in the model, quietly biasing the numbers you're reading, and no amount of extra data will fix it. On the other side, if you include things that don't matter, you lose precision. So the whole game ends up being a deliberate choice, trading a little bit of bias against a little bit of variance, instead of letting a careless model make that trade for you.